Hey guys, we posted a couple videos of the new laser welder we got, and we're getting inundated with questions, concerns. Obviously there's going to be that with any new piece of equipment. So we're going to start at ground zero. You probably, hopefully you saw this that we welded last night. We used a wire feed. And did the bend test on it, and it clearly passed in my eyes. Now people are asking me about the pull test. I really have no way of pulling it unless we hook it between two trucks. We may do that, I don't know. I have some plans. But we're going to start at ground zero. This has a cleaning mode, cleans corrosion and other coatings and oils. Before you weld, they have a pre and a post clean if you want it. So we cut some quite a few coupons out. We're going to start from ground zero, as I said. We're going to clean. We're going to fusion weld today too. Like I said, yesterday we used a wire feeder on this, and we got it dialed in pretty good. And we just played with it for maybe an hour or so. But you can see, as I showed, the heat affected zone was almost nothing. And you can get your heat affected zone down to 85% anyway. Great time saver in your planishing and metal finishing. We're going to planish some welds today too, because I had questions on that. And I can tell you, I took a grinder quick. I did hammer test on the bench yesterday. I didn't show it in the video, but I did hammer test, and it started flattening it out. It's definitely not as hard as a MIG weld would be. It's like a TIG weld or a gas weld, but we're going to put it through the test today. So stay tuned. We're going to get some of these things set up. We'll get it in cleaning mode. We're going to start there, and we're going to show you what we do, and we're going to learn as much as you do today. So stick around. All right, so we're set up for cleaning mode. We dialed it down to about half of what the wattage was on it to start with. We're at 600 watts. 15 millimeters width or length is what they call it. That is the distance it will go across with this tip. We're going to have Scott clean a piece of this metal, this rusty corroded metal up, and we'll see what it does. Now, this does create some slag or sparks like MIG welding does, but the slag does not stick to the parent metal. So there's less cleanup in that. That's just part of the process. Okay, so you can see, cleaned that right up, and look, it's warm. But it didn't get hot enough to really create the warpage. Now, how cool is that? So let's do this. Let's do this spot over here, Scott. That's got a little more build up on it. Let's see what it does there. Now with this system, the tips has to be contacting the metal at all times or it won't work. This is a two-stage gun. The bottom trigger, which is down below, starts the gas which is this. This works the high energy light, the laser part of it, to create this. Now, obviously, this is a little more corroded than this, so we may have to dial it up, the amperage, a little bit. Let's go to 800. Let's dial it up to 200 more. Okay, so let's try that in a new spot. We'll see what that does. Okay, so it's a little bit better. How about, let's go back over that spot the second time and see if that cleans that up. Yeah, you can see it definitely, the second pass. So what that means is we're at 600 here, and this one and this one we went up to 800 watts. So if we just keep this at 600 and make 2 passes, that should clean it up pretty good. And you see here, obviously, the more wattage you get, the more distortion you're going to have. So yeah, let's dial it back down to 600. We'll make a couple passes over here. And we got this stuff out. It's been outside for a while, so obviously it's pretty corroded. Alright, let's do it again. We'll do half and clean that up. Now you have to have a good connection with this. As I said, the gun has to be touching the bare metal. This is using photons of light and not electrical current. So, unlike TIG welding, you know, you get zapped once in a while if you're not careful. This doesn't use the hertz, you know, the amperage and the hertz that a TIG and MIG uses. So we're running off of wattage. All right, start there, Scott, and let's clean that up one more time. We'll see what happens. So we got a little heat affected zone there where he started and held it. This is all a learning process for us. So as much as you guys, but you can see up here a little where he started, the little heat affected zone. So I imagine if you start dragging it after you initialize the gas and before you start the second trigger for the actual laser, probably can eliminate that. And it's still not that bad, but that's a cleaning process that you can see in the backside where the little heat came through there, where the heat affected zones, where he started and stopped at. But that could be eliminated, or at least rectified a little as we learn, and get to use this system more. But all right, we're going to clean a couple of coupons here. We're going to start with a butt weld. We're going to fusion weld this. So we're going to get set up. We're going to clean these, and then we're going to fusion butt weld them, because I've had a ton of questions about planishing and finishing these, as I maybe mentioned earlier. But we got to go through the process. We got to learn this, so you guys are going to watch as we do this. We've had maybe at this point probably less than 2 hours of playing with this thing, so we got a long way to go. This is all mild steel we're working with now. We're gonna learn that quick before we go over to aluminum, in which we're going to be using on Coupe Simone for the entire sheet metal body of that thing. So we're going to be doing a lot of aluminum work, and this is all 18 gauge steel that we're using here. So that's what we use predominantly when we're metal shaping any vehicles, that are in the steel. So, all right, we're going to get set up, and let's see what he's already got them clamped down. So let's see what we can do. All right, look at that, guys. I mean, just like that. You see all these advertisement videos of all this stuff in there, and people think it's fake, but this is the real deal. So, and there again, little heat affected zone where he started. It's not terrible. It's really not that hot. I mean, I can touch it, so. It cools down that quick. It's a lot less heat than, as I said before, either gas, MIG, or TIG welding, Just think how much this is going to save on planishing and metal finishing. So, all right, we're going to flip these over. We might as well just clean the back side, and we're going to get set up to fusion weld. So stick around. All right. Ooh. Roll it. Cleaning the back side of this. It was pretty corroded too, so we may as well just do both sides. It's quick, just like that. And as I said, we're going to fusion weld these two pieces together, and we'll planish. We'll put it through a bend test, and then we'll planish it. Probably we'll do that before we actually give it the bend test. So this is the real deal, guys. So Scott's putting the welding tip back on it. This is a quick disconnect. You just twist it, pull it off. You put your tips on and off. This down here, this is actually the wire feed. That's the liner. This has a steel liner within it. Quick, you can pull them out, switch them over to a plastic one, and switch our drive wheels out, which are obviously inside the wire feeder. Now for fusion welding and cleaning, obviously we don't even need the wire feeder on. But inside here, these two, you just quick connect them, untension them, and swap these over. Right now, we're using 030 wire, and these are V-drive 030 wheels that are in there. But the aluminum would take a U-groove instead of a V-groove, so we have a whole assortment of wheels and sizes down here. So, okay. All right, so we took about 5 minutes to learn the settings. We got into the fusion weld that's pre-programmed. They have different ones for different thicknesses. And one of the pre-programmed ones is for 40 thousandths. Now we're using 18 gauge, that is 50 thousandths. So we just had to find the wattage setting, and we also created the wobble frequency and the wobble length or width. They call it length, and that is the side-to-side motion that the laser actually uses, and the higher the frequency, the faster it's going to run. So I just set it at 10, and we did a couple of quick passes here. Now this one and this one, Scott actually sped up a little bit. So what we're seeing here, this one and this one, he slowed down with. So we're getting this heat affected zone. We're going too fast, and the gas that we're using nitrogen for the steel and argon for the aluminum. And when he went faster, it didn't give time for the gas to properly cool it. So he slowed back down and created these two. So this is all part of the learning process. Now, he can either slow down a little bit like he did here, or we can turn the gas up a little bit, the regulator, to compensate for that. So, and this is all going to be in the user's comfortability, you know. So right now we have two pieces, the ones that we cleaned. He's going to fusion weld these, and let's see what happens here. We're going to put it through some tests after he does this, and we're going to keep trying different things. So Scott, go ahead and try to get behind him here a little bit so I can zoom in on him. Now again, the tip has to be contacted to the metal at all times for this to work. So, gonna touch that up a little bit there, I guess. See, you went a little faster and created that heat affected zone because the gas didn't have a chance to cool it as it was progressing. So, all right, let's see what we got on the back side. Stuck to the copper. So look, you can tell it penetrated. Absolutely. I mean, look at that. I'm touching it already, you know, even up in here. Look at that. Just by using this copper plate. That's the top side. Flip it over again. And we didn't even clean this back side, obviously. Well, I guess we did, didn't we? Yeah, oh, that's right. We did do both sides on this one. Okay. But look at the heat affected zone on that, guys. Get down here as close as I can get. I mean, it's still flat. Come on. That's just about crazy. Wow. Okay. So we're going to run it through the planisher quick. We really don't need to because this was fusion welded. We can just dress it up. But we're gonna run it through the planisher anyways, and then we'll put it in the brake and see what happens there. Stay tuned. All right, guys. So this is the piece that we fusion welded. We cleaned it on both sides, and then we fusion welded. This really needs no planishing. I mean, if you can see this, it's really dressed nice already, you know, but I'm going to run it through the planation hammer, and then we're going to take it over to the brake, and we're going to put it through that bend test. So. We're going to use this mini power hammer by Woodford. It really did nothing because there wasn't really a weld bead to even knock down. So let's go over to the bender. Alright, so it doesn't really matter which side we put it in, whether it's up or down, but it's, I'm going to get it right on that weld, right next to it as close as we can. So, there's a 130-degree angle I do believe that goes to. Yeah. Let me get a hammer.
Take this hammer. One hand.
Stand sideways.
Stand sideways.
All right. So.
Green light here.
Guys. I don't know if you guys are impressed, but I am. I'll tell you. Yes, this was a fusion weld. Wow. All right, we're going to get set up here for the wire feed side again. We're going to redo everything. We're going to planish. We're going to bend it. We're going to put it through the test of time. So my son just came. He's never seen this or worked with one, so we're going to have him up and running this in no time at all. Really, you don't need the experience. In some cases, it's probably better if you don't have any welding experience on MIG or TIG, because you don't use the same techniques you normally would with those. So, yeah, I'm dumbfounded. That's the word, the terminology that I've been using is dumbfounded. All right, so my son has some welding experience making TIG, but he has none with the laser welder either, and he just walked into the shop. So we're going to let him weld this butt joint. He did just a couple of test welds there, you know, just to see. We gave him a quick test on it, but
I got off track.
yeah, you got off track there, but you were doing good up to that point. Here, cut your wire. Oh, you got it there. Okay, never mind. Yep. You got off the weld bead, or the butt joint. It takes a little practice. Yeah, trust me, I wandered off of, veered off of those too. Just let it feed right off of the metal.
Yeah, I was trying to stop on
Hey, for your first time though, You got the weld bead okay. You know, the speed was good. Now our gas had dropped a little bit. I noticed that it was down. We have it set at about 20 psi right now, and obviously that helps with the heat affected zone, the weld cooling. But what you can do, you can put a guide down along the side of it and go that way. Now you're using the tip that we can normally use for a lap joint or a T-joint. Okay, you would put that in at a 45-degree angle. That tip would be in that joint at a 45-degree angle. So yeah, that would be about maybe a little bit more or less, but that's how you would do that. Or a lap joint. We can actually tack weld too, and then you would have your gun at a 45-degree angle and just rest that tip of that in there, and we'll do that too. So let me get you set up. All right, so we got this unclamped. Now you can see he made several passes because he wasn't running it straight. So there's more bead weld on there than what we really needed. You can see the penetration. It even stuck to this a little bit, so I had to pry it up a little bit with a screwdriver to the copper plate. But let's put this in the planishing hammer because, as I said, there's been a ton of questions, you know, how the weld bead planishes out. So we're about to find out. Okay, guys, so we're here with the mini hot rod power hammer, and you can see has several passes of welds because Devin got off on it, and we needed a complete butt lift. So you can see it complete penetration. But let's see what we can do with dressing up these welds, planishing them out. I mean, it knocked them down some. I could adjust this a little more, get it even tighter. I want to go over to the brake. It looked like maybe right here I can still see the seam. I don't know if you guys can see that or not, where it wasn't on the butt joint. So let's take this over to the brake and see what happens. Alright, so this is the piece that Devin welded. We put on the planisher a little bit. Let's get in here, see what happens. As I said, there's a spot that of the butt weld that was completely missed. So okay. So you can see there now where he missed the welds of the butt joint. But let's just see how strong this is over here and over here. So, all right, we're going to take it over to the table and beat on it. All right, so here we are. I'm going to do a little hammer on this and see what happens. There was where it was completely missed with the butt joint. Now, obviously, as metals work, it's going to work harder more. But look, it broke off outside the weld edge. And not in the weld itself. Alright, we're going to take a lunch break, and then we'll do a weld that has, a butt weld that has been completely welded the whole length, and we'll put it through the same test as this one, and then we'll do some tack welds and T-welds or butt welds. We're going to show you the whole process of the mild steel. But so far, so good. We're going to try a tack weld now. We're in the tack weld setting, and supposed to count to 5 basically. So let's see here. Okay. Got a nice tack there. Well, obviously we got penetration. So let's try to break that apart. See if you can pull that apart, Scott. Yep, you did. Okay. So that means we need a little more heat, a little more wattage. Okay, so we're in FO. I'm not sure, continuous F1. That says tack. Let's do 850. We'll see where we're at there. Okay. Well, you know what? I didn't set the length or the frequency of the wobble. So go ahead and see if you can break that one apart.
Yeah, that one break.
Did it?
Yeah.
Oh yeah. Okay. So yeah, we got penetration. It looks like it's just no width. Do a 3mm side there. Slip. See what we got.
pretty strong.
Yeah.
It'll break, but it's strong. That was 2 tacks.
Okay. Let's put one more on there and see what we got there. Yep, see, we got full penetration through that. Doesn't look like much on top. Go ahead and
It's strong for a tack. But
for
I mean,
attack, yeah. Okay. All right. So that's just one mode. We have to play with the machine more, obviously, but want to show what this machine, can do. Reviewing everything quickly. So let's set up for a butt joint, or I'm sorry, a lap joint, and then we'll do a T-joint, and we'll be back. Okay, literally look at the size of that. Get my camera in there, sorry. Literally, it's just a little nick. All right, here's a scribe there. I mean, come on, look at that. Now let's turn it over. We'll look at the back side. Maybe. There we go. And look there. That is the penetration point. See what you can do with that, Scott. I mean, seriously. One little stinking tack that's literally I don't know, 3 millimeters wide, maybe 2, 3, and maybe a millimeter, or I should say long, and then about a millimeter thick by 3 millimeters long. And you can't even hardly see that. I mean, come on, that's freaking crazy. I think we got it dialed in. Pretty damn close, so wow. That's a tack weld. So we're going to try a lap weld. With the wire feeder. Okay. So the first part, you can see he slowed down. Or I'm sorry, he was going too fast. And we got, the gas didn't have enough time to shield. So we got a wider heat affected zone than here. Look at that clean weld though. This is what we need to work on to get the feel for the machine and how that it works. So we'll do another test. We'll do a second one. A bit of a gap in that. Yeah, let's put this one on maybe. Just to help keep it down there better. Yeah, let's try that. Now what he's doing here is adjusting the wire to where that red light is right at the tip of it. Wow, okay. Now that is extremely nice looking weld. Now we're going to have to test the strength of it. Flip it over. Nice penetration through that. You can see the all the heat ranges. Very minimal weld, width wise. Let's. You think you can break that?
That'll do it. By hand?
I don't know.
I ain't gonna break my hand.
No, I doubt by hand. Let's put it in the. Let's take it over to the vise and check it out. We got it in the vise. You can see the weld down here. We're gonna put it through its paces. We'll see what this can hold up to. Okay. There we go. Let's see where this. Man, it's taking a lot, I'll tell you. Give up? You get tired? Unbelievable. That was close to a minute he worked at. And I don't think there's any signs that I can see of really failure on that. Do you? You see any?
Looks good.
Yeah, I mean, what can I say other than I'm still dumbfounded, you know. Wow. All right. So that was a lap test. Let's do T-joint. See what we come up with. We'll just do the one side, just like this is one-sided. So, all right, off to the T-joint. Okay, so now we're doing a T-joint. I'm on the wrong side of him, but we got to be able to see this. Look how fast and smooth that is, guys. That heat affected zone is like nothing. Come on. Let me take you in here closer. I got to zoom out so I can get.
That was my first time.
That was his very first time doing a T-joint. We didn't practice this or nothing. I mean, there we are. There's the penetration of it. Look at the warpage. I mean, this is a little bit warm, but nothing like it would be if it was MIG or TIG. Obviously, because the heat affected zone isn't there like it would be with that. So this is the backside where the weld came through. We got penetration there. You can see that. So let's go back to the vise and see what this one does. All right, so we're back over at the vise. Oh, he's got to go get clamps and let them lay over there. I'm still, guys, I've been in the auto industry, auto body industry, collision industry for 42 years. I hate to admit that I'm starting to get old. I think I started when I was 14. And I started out with oxyacetylene welding and brazing, and you know, then MIG, and then I got a TIG, and this is just crazy. He's going to break that one off. Yep, he broke it off, but it took a little bit. But where did it break? Did it break in the weld alongside of it?
So it broke right down the middle.
Down the middle? Okay. So we have obviously settings that we can really change. Yeah, okay. So you can see this is the weld side of it. It's possible we may, all we can do is change some settings on this and then try it again, because we just pulled up a preset basically with a wire feeder, and that was still a very clean. I mean, it was absolutely a nice beat, but we got penetration. You know, we don't have the width built up on it though either. You know, we might have to, our wobble length or width. We might be able to do something else. I'm still impressed with this outcome. I mean, he had to work that a little bit, but not like the lap joint that we couldn't break. So let's make a couple little adjustments, and we'll try test number 2 on a T-butt, or a T-joint, excuse me. Okay, so we made a wattage adjustment to turn the heat up a little bit. He's going to re-weld a piece onto that. This is where it broke off. He's just going to flip it over and re-weld. We'll see if turning the heat up. That honestly, it was turned down to 400 watts. Now you see how he worked that wire in and out? Quick touches of the trigger will pull that in or bring it out where you need it. Okay. There we are again, guys. Let me zoom out. Well, we got fastened right to the okay, so here is the back side again. Looks like we got penetration definitely better in there on that side. Let's check the bottom. Oh yeah, we got, you can see it definitely better than the first one below it. So all right, let's back over to the vise. All right. This is test number 2. We turned the wattage up a little bit for our T-joint. Let them work it again here. Let's see. It's hanging on, but it's taking a bit. I think it'll obviously come off there at some point. Definitely got what we needed in penetration then. Yeah. There it comes. He's got it. There it is. You're missing some sheet metal. Look at that. It didn't break the weld. It broke the frickin' sheet metal. Look at that. Are you guys impressed yet? I know I am. This is crazy. Crazy. Wow. Okay, so I had people asking about welding a gap, planishing it. So what we're going to do, we're going to try this. We haven't done this yet off camera. We're going to try to fill a gap. We left, I don't know, a mil or so in there. Maybe 3/4 of a mil to a mil. It looks like it's a little tighter there than it is down here. But we're going to try to weld this. We'll planish it out and metal finish it to see what it looks like, because I had a lot of questions on the metal finishing side of it, whether it's going to be porous. You know, we don't know. And there's buildup on this copper plate that we have underneath here, so, you know, we're going to see. All right. Oh, you got a little speckage there on the end of it. So, let's see. Oh, where we at? All right. So, apparently it wasn't lined up. We welded to one side. For some reason, you can see that's got to be user error. We did something wrong there. Let's give it another shot here. I changed the wobble length on this. Let me back it back down. I don't know if that would affect anything or not, but we're gonna see. All right.
I put that thing up to 5. That's a big gap there.
I did have it at 5.
It was.
Yeah, because of that gap, and I don't know why it shot off to one side. So we put it to 2. We'll see what happens. Excuse me. We're definitely not professionals at this with this machine yet. You know, we've only got 4 or 5 hours on it, playing around with different things.
Tell
But
you what, to do a gap, you gotta be a welder.
yeah, okay. So let's take it over. We'll planish it. It looks like we got a little bit of porosity there, a couple spots, maybe. Got a little bit of more heat affected zone than we like, but here again, this is just the test that we're doing, so we know what it's capable of, and we'll get things dialed in. There's the penetration. So there's the back side of it. Looks like, yeah. All we can do is planish it and see what happens, right? And then we'll grind and dress the welds up. All right, guys, so this is the piece we just planished, or I just planished, I should say. You can see it knocked it down some. And there was the couple of porosity spots. And I'm sure it came from the dirty copper come up through. So let me do a little grinding on this. See if we can dress it up. one-handed, so. I could switch to a flap wheel, but I normally do. No, I mean, this disappeared here. I mean, this is hotter from grinding than it was from welding. So, that little shoulder there. I think this is 80 grit that I have on here. It's not taking a ton of it, but I could probably planish that a little bit, get it flattened out a little bit more, and the rest of that will come right out of there. I mean, does that answer anybody's questions about dressing it up? I hope so. So there you can see those two little porosity marks. All right, there's three. But again, that I'm sure came from this copper plate, so we don't weld this to the metal table. So, yeah. I hope that takes care of some of the questions that I've gotten in the last 24 hours. But we're going to keep testing things. I mean, we're not even done with mild steel yet, and we're still on 18 gauge. But we'll probably switch over to aluminum before too long, sometime probably this week. You know, we got to kind of work between other things and do these tests, the welds and tests and stuff. So I am 100% impressed so far. I mean, you're seeing it for yourself, just like we are really for the first time. You know, proper PPE should be always a must. You know, we have special glasses rated for infrared up to 1070 nanometers. Plus we have helmets that we wear on top of that when we're welding. And you know, your gloves and your welding jacket and stuff, you always should be protected no matter what welder you're using. But as most people do, you know, they lack in that. But this takes infrared light. This uses infrared, this emits infrared light. Not like your traditional welders where there's ultraviolet light coming off. Both can really damage your eyes and your skin. So it's no different really. You want to, you know, prep yourself with all the safety gear. You know, have the proper space. You don't want to have a bunch of explosive materials or you know, flammable stuff anywhere near. See, you did notice it puts sparks off, but it's not slag like a MIG welder would do. You would have, you know, slag build up here and there, and you have to clean all that. Now it's just incredible. So I don't know if we'll get any more tests in today. I gotta think of something else we can do with this 18 gauge. We covered the cleaning. We started with the cleaning. We went. That was a lap joint. Okay, that was a lap joint that we could not break. We did spot welds, tack welds, excuse me. And Scott just did this one quick. He clamped it to the table because, you know, there might be people saying, well, you got a backer behind it. What can it do without? Now, he just set this up with the wattage we use for other ones. And we actually had the heat turned up a little bit. So if we turn this back down to where the 400 range where it was, there probably wouldn't be any burn through. But look at that. That was welding with that clamp to the table. And I thought I was recording, but I wasn't. This was the T-joint, I think. Yes, this was the second try with a T-joint. He worked that metal until it broke above the weld. Obviously, you can see that. This is actually the weld side. The first time, well, actually the second time he did the T-joint. So with first time, we was able to break it, in which, you know, we were testing it. You just had to turn the heat up, the wattage up a little bit, and this was the result of complete penetration. And he was not able to break that weld at the weld joint. So there you have it for mild steel and 18 gauge. I'm sure we'll be doing some more testing on heavier stuff here at some point. We got to get set up so we can weld aluminum and start the panels on Coupe Simone's soon. So we really need to get practicing on that, because we're going to have a mile worth of welds or more to do on that thing, as big as that car is. So, all right, guys. I hope this answers some of your questions for the LightWeld XR by IPG Photonics. This is the newest of the handheld laser welders systems that they have to offer. The XC and the XR both have a cleaning process that there's programmed into it. The LightWeld 1500, I do not believe has a cleaning. It's lower priced, obviously. This is the newest model and the most expensive, but this realistically wasn't made for the home hobbyist. You know, if you have a business of any sort that does fabrication work, you know, obviously sheet metal work, whether you're, you know, a coach builder, restoration shop, auto body, collision, this thing is going to change the collision industry. Why? Because it doesn't use hertz like the other welders do. You don't have to worry about the onboard computer system in a car being affected by lights of photon. You have to worry about that with the electrical currents and the hertz that go through the other traditional welders. You saw the butt welds that are required, and in the auto body industry, or in the auto collision industry, there must be a backer behind any butt joint, okay? I don't like doing lap welds because it creates sandwich rust, is what they call it, in between the two panels. We have to check yet. We have to try it with weld through primer on this. So that may be one more test that we do. As a matter of fact, I think I'll get set up. I think I'll go get the weld through primer, and we're going to try that quick. We're going to try maybe a tack joint, and then we'll do a lap joint, or yeah, we'll try it with a lap joint and see what happens. So, all right, stay tuned for that. All right, so we put weld through primer on a piece of metal, and we put two pieces over top, and just a slight gap. We're going to see what this welder can do with the backing plate with the weld through primer. Normally you would have it 2 inches. They require on both sides for a lot of different things for a backer plate. But we're going to weld this up and see what happens. We didn't change any settings or any wattage or anything like that. So we got some porosity in there. It looks like we needed more. What are we at there? Yeah, we're at 500 watts. We left it where it was. Let's take the clamps off and look at it, I guess. See what happens. Obviously, we got some penetration. We can turn the weld up, though, definitely. We can turn the wattage up a little bit on that. We're actually welding through 2 thicknesses instead of the 1 now, so see if you can bend that for a spot. A pair of pliers or anything there? Or... Oh, sorry guys, I didn't realize I was still zoomed out. Yeah, so it's definitely penetrated enough. I think, honestly, I could see turning it up to maybe 600 to make sure. Obviously, we would put weld-through primer on the back too if we were working on a car. But we just wanted to see for this test, you know, whether it would stick. And obviously, it's working through the weld-through primer. Look at this weld dressing again. And straighten this back out. If you were putting a quarter panel and you spliced it up in the sail panel, how much work would you have to do to have that ready for primer? Seriously. Really? The heat affected zone is extremely minimal. Obviously the durability is there. This is the first test we've done with the weld through primer, and we just left it on the settings for a normal butt weld, not for 2 thicknesses. So I really feel comfortable if we jack the wattage up 50 to 100. We would have complete penetration through that, and it would be right there with any standards, iCar or whatever, the manufacturer standards. I would stand behind that. This is the galvanized 22 gauge. Cleaning mode. As I said, you always want to wear proper respirator and, you know, PPE with anything, especially the galvanized. So we just wanted to do a quick test for that.